So factorisation of cubic polynomials is very similar to quadratics. Again, the key thing here is that if the coefficients are real, we have a particular result, which is at least one factor must be real, okay? And then complex factors occur in pairs, as we've seen before. So that's the difference between this one and the quadratic, is that at least one of the factors will be a real factor, and that's because we have one more power here than we did before. So we're either going to have 3 real factors, or we're going to have 1 real factor and 2 complex factors to occur in conjugate pairs. Think about, why can't we have 3 complex factors? That's because your complex factors need to occur in pairs. And because you're only going to have 3 factors here, you can't have 2 pairs. That would be 4 factors. So you're guaranteed to at least have 1 real factor. So let's look at the first example here. We're going to work on factorising this. So our polynomial is z cubed plus z to the power of 2 plus 4. Now what we have to do here, which is a little bit slightly awkward, I suppose, is we need to actually guess one of the factors. And we guess that, looking at this number, it's quite low. We guess this by trying different values here. So we're going to try different z such that p of z equals 0. That's going to give us a solution. So we're basically trying to find different solutions here. Now the ones to try usually small numbers. So try, plus or minus 1, plus or minus 2, and work up from there. With this example here, if you think about it, if you put plus 1 in here, these are all going to be positive. Same if you put plus 2, everything's positive. The only way this is going to work is if we put a negative number in here. This will become positive, but this will become negative, and we'll hopefully be able to get 0. So we're going to try each of them. Try negative 1. So we're only going to try negative 1, negative 2, and you can keep going, negative 3, and so on until you get a result. I'll put negative 1 in, so you can see I'm using brackets around it just to make sure I don't do anything wrong with the signs. Negative 1 cubed is negative 1, negative 1 squared is 1 plus 4, and that's going to be 4. So that's not going to work for us because we want to have our solution as 0 here. So let's try with negative 2. Now you can probably see if I put negative 2 in here, I'm going to get negative 8. And that, hopefully, is enough to get 0. So we're going to get negative 8 here, and negative cubed. Negative 2 squared is 4, plus 4. And cool, it's 0. So therefore, what that tells us is that z equals negative 2 is a solution. And by the factor theorem, that also means that a factor for this is z plus 2. Remember that the factor is anything so that you have this solution solved equal to 0. Because if you take the negative 2 over to this side, it becomes plus 2. So that's where we get that factor, always the opposite sign in the factor, from the fact that you're actually solving this equals 0. So now we've got one factor. We're actually going to find the other factors. So find the other factors by, now this is going to require division of polynomials, and you would have done this polynomials in methods. So what we're going to do here is take our factor that we have, so z plus 2, and we're going to divide that into our factor, into our polynomial here, into p, because we want to find out what the other factors are. Now for division, I'll do this in a light blue. What we do, you need a z cubed first of all, so straight up you're going to need a z here. Now what we need to do is multiply the z with each of the terms here. Okay, so we're going to have z squared and z 2z. And that's not enough for us because we want z cubed, so that means you're going to have a squared here. Now if we multiply, we're going to have z cubed, I'm going to write that underneath, plus 2z, and that's z squared. Okay, so what you've done is you've done the first step now of your division of polynomials. Now the other thing that's a good idea, can you see here that we've got z cubed, z squared, and there's no z in here? It's a good idea when you're doing division to actually put a placeholder there for any powers of z that you don't have. So I have no z's, but I just have a constant. So actually put a placeholder there, and you'll see why in a second, why that's useful. What we need to do for the next step is subtract what you got when you multiplied this answer from the top. So z cubed minus z cubed, that's 0. Z squared minus 2z squared, that is negative 1z squared. Okay, and then bring down the other things that you have, the 0z and the plus 4. So now we're going to look at this line here. So I'll do this again in light blue. So we've got z plus 2. To get a minus z squared, I'm going to need to multiply, put a minus z here, because if I do minus z times z, you're going to have minus z squared. That will get rid of that. And then let's also multiply the minus z by 2. You're going to get minus 2z. Okay. So now if we look, next line, we've got each of these expressions here. What we're going to do now is take away that from this line. So we now have underneath, let's put another line, we've got negative z squared plus z squared, that's 0, that should always cancel. I've got z plus 2z. I'm going to bring that plus 4 down as well. Okay, and hopefully you can see now this is going to work out really nicely. We need to put another thing up here in our answer. Okay, so we've got 2z plus 4, and to get the 2z here, we're going to have to multiply z by plus 2. So we're going to have plus 2. So let's check that it works. We've got 2z, multiply that over, put that underneath, 2z, and then multiply this number, plus 4. And the awesome thing there is we've got no remainder. So that means we've actually finished with our division now. So we've got here, for this particular expression so far, we've got two factors. This one is one factor, and this one is another factor. So we're nearly finished factorising. This isn't a linear form yet, but these are our two factors that we have so far. So let's copy those. So we've got this expression, remember this is what we're dealing with. I'll just put this on the next page so we can see. Copy this one. This is one of our factors. So these questions can be quite long, so it's always a good idea to leave yourself a fair bit of room to work them out. Right, cool. Alright, so we've got this so far. Let's put some brackets in. So what we've determined so far is that this expression can be expressed now as this. Now we're going to factorise this part now. And to factorise that, we can use completing the square. So we have, let's just think about this part. Let's not worry about this for now. We've got z squared minus z. Halve that number there, which is a 1. Halve it, which is a half. Square it, which is a quarter. Add it, subtract it. Add on the rest. So we're just using completing the square. This should be a perfect square. This is going to be z minus a half all squared. Okay, minus a half z minus a half z will give you minus z, so that's cool. I'm just putting this 2 over 4 so that it's easier to work with here. This is going to be minus 7, plus 7 over 4. Now again, we want to try and manufacture a negative sign here. How do we do that? We multiply by I squared. So we turn this into a negative and we multiply by I squared. Now we can take this term, pick it up, put it in here, provided we do plus minus the square root when we put it in. So we've got z minus a half, plus root 7 over the square root of 4 is 2, the square root of I squared is I, and the other bracket will be minus root 7 over 2i. So therefore, what we've shown is that for pz, which equals z cubed plus z squared plus 4, this is equal to 3 factors. The first factor, which we found by essentially guessing, okay, putting in a negative 2, find a solution. The second factor we got by division. Okay, so remember we went back here and we used division of polynomials to get that next factor. And then we factorised that by using completing the square. So completing the square, then we end up with the two factors, complex conjugates, and as a shorthand, you can always write this as plus or minus root 7 to I as well if you want to. But I tend to actually write, I'll get rid of one of those, get rid of the minus. I tend to write out both just because I think it's, sometimes you can miss that when you're putting in solutions. So 3 factors there for that one. And remember, because this started off as all real coefficients, we've got 2 complex conjugates and 1 real factor. And that's how we know we can guess those factors at the beginning. We know we're guaranteed to get a real factor. All right. The next example here, which I'll do, is this one. And for this factor, this actually has a nice trick in it, which is a really useful trick you can use in your exams. So looking at this, the thing that I find here is a little pattern. Okay, maths is all about identifying patterns. That's the key thing about mathematics. And if you have a look here, what you may notice is that each of these has the same kind of look about it. It's like a Z. This term is 1 power Z more than this one, and the second term has an I. So what that tells you is that you could probably look at this Z minus I thing that's going on here and try and factor that out. And let's have a look. We'll do it by hand. So we've got Z minus I. I'm going to take Z minus I out as a factor. Z minus I, if I times that by Z, okay, but by Z squared to get the cube, that would be that's going to be my Z cubed part, okay. And what I'm going to do then is have a look at minus I times Z squared. That will give me that as well. So that's really cool. And if we do the same thing over here, can you see you've got 4 that's in common here? It's probably a 4, but let's try that as well. So I'm going to have plus Z minus I. It's that recognition that Z minus I is common. Actually, I'll put brackets around there. And again, we're going to have a look here. Let's think about if I multiply this by minus 4, let's check. We'd have Z minus 4, Z times minus 4, which is minus 4Z. And here we'd have plus 4I. Sweet, that works. So we can actually factor out the Z minus 1, Z minus I should say. So we have that it equals Z minus I, because that's common to both. And what are we left with? We had the Z squared and the minus 4. Okay, now this guy here is going to work out nicely, okay, because it's going to be a difference of squares here. So if we have a look at this now, we've got Z minus I, and here we're going to have Z plus 2 and Z minus 2. Now you might be saying to yourself at this point, hey, we didn't get a complex conjugate partner for this complex factor. Have a look back at the question. There are complex coefficients up here. So there's no guarantee that you're going to get complex conjugates with this one. So this particular example actually has 2 real factors, those 2 real factors, and it has only 1 complex factor. And that's purely because you've got complex coefficients in the original polynomial. So this one has a special trick to it. It's about identifying what's similar, what's the pattern that's going on here, and identifying this Z minus I comes out as a factor in both pieces here, and then being able to factorize it into the 3 linear factors. You again expect 3 linear factors because this is a cubic, so you'll always get 3 linear factors. If all real coefficients, 1 will be real or all real, then a complex conjugate pair. If you have complex coefficients, there's no way of knowing the form of your final answers or your final factors.